Hello, and I want to welcome you to another exciting discussion on mathematics. Today the topic will be exponents. This topic will break down into two videos, this video and another following. Part 1 of this, we're going to just give a discussion of exponents, a talk about the power rule, and a talk about the product rule. So let's get started. For a general discussion on exponents, let's talk about what they are. So we have this expression right here, where we have a large 2 raised to a small 5. We say that 2 raised to the 5th power. Okay, and what does that look like? Well, that just means take the large number and multiply it by itself as many times as the small number is. So, that means take 2 and multiply by itself 5 times. That's not to say 2 times 5. That's to say 2 times 2 times 2 times 2 times 2, or written like this: 2 times 2 times 2 times 2 times 2, and that's 1, 2, 3, 4, 5. So that's 2 multiplying by itself 5 times, excuse me. So that says multiply 2 by itself 5 times for this expression right here. So let's go ahead and give a generic term. We have right here a to the nth power, where up here a would have been 2 and n would have been 5. So let's describe what these are. The large number is called the base. And as you might have guessed, that n is called an exponent, or power. But for this, we'll just label it exponent. But remember, it can be referred to as a power. Okay, so now we're asked to evaluate each of these expressions. Just as this first example, what we were talking about by discussion, we could evaluate what this is. That's what we're going to do down here. Examples. Evaluate each of the following expressions. So first, I think it's important to write out exactly what each means. So 2 to the 3rd power, that would just simply mean 2 times 2 times 2. That's not saying 2 times 3, that's saying multiply 2 by itself 3 times. So to do that, we say 2 times 2 is 4 times 2 is 8. So 2 to the 3rd power is equal to 8. Okay, for this one, 3 to the 1st power, we have just multiplying 3 by itself 1 time, so we're just saying 3. And that's the answer. Okay, now let's get into something a bit more tricky. So we have negative 4 to the 2nd power. Recognize C and D down here. They both look very similar, but we're going to get some different answers. To evaluate this first one, what we have to say is we have to bring the negative out in front, open up parentheses, and then evaluate the expression 4 times 4 to represent 4 squared, or 4 to the 2nd power. So when we evaluate that, we're going to get a negative, and then what's inside that parentheses, 16. Let's say you want to evaluate something that looks like that. Now to evaluate something D, like D, we're going to have, as you might guess, negative 4 times itself as many times as the power says, or something like this. A negative 4 in parentheses times a negative 4 in parentheses. And what's a negative times a negative? Well, that's a positive. And what's 4 times 4? That's positive 16. So we have a positive 16. Notice that you get different answers. That's just based on how the expression is originally written. Okay, now let's move into something where we have an exponent times just a regular real number. So what I'd like to do is bring the 4 on down and then evaluate what that exponent is. What's 3 times 3? 3 times 3, well, 3 times 3 is just 9. So you can just rewrite 3 squared as a 9. So 4 times 9 is equal to 36. Okay, for this next set right here, it's just going to give an expression, and then it's going to say when x is equal to something. All you have to do is plug whatever x is equal to in for x. So for this, start off by saying 2, and then where the x is, I like to open up parentheses, place whatever it's equal to, which is 5 in this case, and then just write your exponent like it was. So the best thing to do now would be like we did over in part E, which just rewrite that too, and then rewrite what this means. So 5 to the third power means 5 times 5 times 5. So we're going to have 2 times 5 times 5 times 5. Okay? And what is 5 to the third, or 5 times 5 times 5 equal to? Well, that's 125. So we can just rewrite that as 2 times 125. And what is 2 times 125? That is equal to 250. We were just breaking down what these exponents mean and writing what they are equivalent to. Okay, for the next part of our discussion, let's talk about the product rule for exponents. Okay, for the product rule for exponents, if m and n are positive integers and a is a real number, then we're going to have a base times an exponent, or a base with an exponent being multiplied by the same base with a different exponent. We're going to see what we can do. So a to the nth power times a to the nth power is equal to a with m plus n as the power. And that's how it looks generically. And then if we look as an example down here, we have the bases are going to be 3. We have the same base as 3, but we have different exponents. So how can we combine this to make one simple term? Well, since they are the same base, just add the exponents together as we did here. We said 5 plus 7, and then we just simplified. So let's do that here with some examples. As you can see, we're going to have some, they all have the same base, and we even have some variable bases here. So let's get started. So I like to rewrite 4 squared times 4 to the 5th power as 4 to the power of 2 plus 5. And what does that reduce to? Well, that reduces to 4 to the 7th power. Let's try it for this one, for part B. If you look, every number that does not have an exponent has that imaginary 1, or that 1, excuse me, up there. And we can just assume that. So now let's combine the 1 and the 3 to make a complete expression. Okay, and we have 5 to the power of 1 plus 3, or that reduces to 5 to the 4th power. Okay, if we look at this next one, we're doing the same thing. We have the same base, so we write that base. We have a 2 and a 4. So if we rewrite that, 2 plus 4, or 3 to the 6th power. Okay, now let's look at the one with the variables. We have the same base of x, so let's just rewrite the x. Now let's look at our exponent. We have a 3 and a 7. We're going to combine that, so let's just add those. 3 plus 7. And what does that expression reduce down to? X to the 10th power. Now let's conclude the video with a discussion on the power rule for exponents. That was the product rule we just talked about. Now let's discuss the product rule. The power rule, excuse me. Okay, for this one, if m and n are positive integers and a is a real number, then we have the base of a with the next exponent of m, and that whole expression is going to be multiplied by the power of m. That's what it looks generically. Now let's see what it would be equal to. It would be equal to a with the power of m times m. So the difference between the product rule and the power rule is that we had two bases that were the same with different exponents. With this we have one base with two different exponents. So use each rule with however many bases or exponents you were given. So let's look at an example of the power rule. Just as a times a to the nth power, all that to the nth power equals this, we can apply it to this example. We have the expression 7 squared, all that to the 5th power. So we can just multiply these exponents together to have the base of 7 to the 2 times 5th power is equal to 7 to the 10th power. Now let's just do some examples. Okay, so we have a and d that have real numbers and for bases, and then b and c will have variables as bases. So let's get started. 5 to the 3rd power, all that to the 6th power. So let's rewrite that as 5 times 3 to the 6th. And to simplify that further, just multiply these exponents together. You have 5 to the 18th power. Okay, now let's keep going. For this one, just write our base down, and then just work with our exponents. 8 times 2. Or y, that will reduce to 16. If we look further down, y is our base, and we have these exponents, 3 times 5, because we're just applying the power rule for exponents. And remember, 3 times 5 is 15. Okay, let's look at this final example. So we rewrite our base, and then let's multiply our exponents together. So we have 2 to the 27th power. Alright, that concludes our brief discussion on exponents. So talk about the product rule and the power rule. That concludes part 1 of exponents.